Good afternoon, and thank you for joining today's webinar from SPEC Innovations, The Path to Digital Engineering. My name is Elizabeth Steiner, and I'll be the moderator for today's webinar. Let's go over some quick housekeeping before we get started. During the presentation, feel free to send us questions using the panel on the right, and we will get them answered in the question and answer part of the webinar. The webinar is being recorded, and we will make it available to you after the live presentation, so be sure to keep an eye out for it in your inbox. Now I'd like to introduce you to your presenter, Dr. Steve Dam. Today he'll be discussing digital engineering, digital twins, and how tool integration plays a role in that path. Dr. Dam is the president and founder of SPEC Innovations. He has been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. Dr. Dam participated in the development of C4ISR architecture framework and DoD architecture framework. He has also received an Expert Systems Engineering Professional certification from INCOSE. He is currently applying systems engineering techniques to various DoD, DOE, and commercial projects. And now I'll hand over the controls to Dr. Dam, and we will get started.
Thanks, Elizabeth. So I, in fact, just got back from a trip to a customer where we're trying to build a digital thread for that customer, and we are using Innoslate as one of the major elements of it to help bring the data and information together. So I'm going to talk a little bit about some things that many of you probably already know what a digital thread is and all that kind of stuff, so I'm not going to bore you with a lot of slides on that, but just a few to catch up people who aren't. And then we'll get into about when we want to integrate tools, why do we want to integrate tools, also how we go about integrating them with Innoslate, and then when should we integrate with other tools and when shouldn't we? Because there are definitely times we don't want to. And then I want to bring up some things that are some pretty clear potential problems that we need to address with digital threads as well. So what's a digital thread? So this is a picture from Phil Zimmerman's presentation back at NDIA back in 2018 at the NDIA conference, Systems Engineering Conference. And the key is that there's actually a defined DoD strategy on this. There's a document you can get. It's been signed out by Mike Griffin. And so it's a very nice document. It kind of gives you the big picture of what's going on. And the goals or objectives are pretty clear. They're looking for how can they speed up the whole process? How can they take what's become decades-long processes, but turn them into something that can happen much more quickly. And part of the way of doing that is through this digital engineering thread. Create a situation where you know what's going on, you capture the information at all phases of the life cycle, and then can even reuse it for the next phase, for the next schedule, development. So this is a way to bring that information all together in one place. But also they want to reform business practices, which will be required if we're going to really do this effectively. So that's going to be a key part. So some of the enabling technologies, first of all, we have to recognize that an enterprise is people, processes, data capabilities, all those things together. It's not just one aspect of them. And so it's going to have to do the improvements, we're going to have to make sure that we can create what they're calling this authoritative source of truth. In other words, that'll end up being a place where you can say, yes, that has validity, that data has validity. I know that's correct information. So this is all very difficult. This is not something that's going to be easy or fast to do, but it's going to require us to combine model-based techniques, digital practices, and a very strong computing infrastructure. So one of the questions we always ask, because we're systems engineers, well, what do we do in this digital thread? Well, DoD actually commissioned the Air Force Research Labs to develop a set of posters to explain what the digital thread would be in each of the phases. And this is the poster on the right you see for the model-based systems engineering, and talking about how we go from a document-based approach into the model-based approach. It's a very interesting kind of thought process. Particularly, there's a thought about early on using high fidelity models, not just high level models, not just highly abstracted models, but high fidelity models early in the life cycle to help make decisions in this early phases. So again, when I look at that though, in a lot of ways, well, we went digital a number of years ago once we got desktop tools and we started using Microsoft Office Suite and things like that. And people still, it's funny because I get people asking me the question, well, who's your competitor? I keep making the joke it's Microsoft Office, because that's what still most people are using for system engineering. It's what they have at their desktop. That's what's easily available. And they can do a lot of the things that we used to do by hand, typing up documents and, making calculations. Well, Excel helps you do that as a spreadsheet. PowerPoint gives me my drawing tool, or Visio. So again, I can do a lot of the things, project planning, use Microsoft Project. So again, heavily that, but they're still kind of just following that same almost manual process to a great extent. The idea with the model-based approach is we're trying to do something more. And we've been using models forever. I mean, this is not a new thing, particularly with the definition of a model that includes drawings or a model, then it's not a big deal. This is something we do. But really what we mean by model-based approach is we want to have the models do more than just represent diagrams and little pieces of information. We want to be able to bring that information together, view the information in many different ways and dimensions, and then work with that information and be able to reuse it as best as possible. So to do that, we need to also be thinking about documents as a model. So you might want to think about your documentation now. If you could actually access a textual kind of document that would include then the diagrams and the tables and all the other information you need, that can give you something even more communicative to a broader group of people. So, but of course, systems engineering, this view of it is just a small part of the whole picture. They had a lot more posters. This is a hierarchy chart showing the different sets of posters. They had, you see A1 through 7, those are 7 different posters that had to do with concept development. And then we had somewhere 8 under the design and test and evaluation kind of posters. And then production had 6 and operations sustainment had 6 as well. So these were all 6. And again, this is just a group of people coming together and saying, these are the kinds of things we ought to be doing. This still isn't probably the complete set of all the things we're going to have to do and pull together in terms of the data sets and information to create this complete picture. So, but one of the things about system engineering that we've learned is that systems engineering is actually very useful all throughout the life cycle and can help guide and bring the information together in a way that you really badly need to be able to communicate to all the stakeholders. So clearly a complete systems engineering approach needs to play a significant role in orchestrating this. And so having the ability then to trace the information back and forth from the requirements all the way through test and evaluation into operations, all the way through disposal. We need to create that closed loop system to bring that information together in one place. So we need to make sure that systems engineering plays a major role in all phases of this life cycle, not just the one poster. So one of the things is the question, well, why do we want to integrate with tools? Well, first of all, the digital engineering strategy made it one of the goals. In fact, it's the first goal in it is model integration. So that's very critical. That obviously there are a number of other goals, model curation, model credibility, all these other factors that are in here that are all part of this. But that model integration is very critical. And the question is, though, do we need always to integrate the models, or is it the data interoperability we're really looking for? Because that's been a big problem. It's been a big problem for a long time. Individual tool vendors have really no incentive to work together. And in fact, they have a lot of disincentives to work together. And so unless there's a clear standard that really works between things, you're never going to have this interoperability we're looking for. So what are we doing with it? Right now, we are actually in the process of integrating with a number of other tools and capabilities. But the fundamental problem had been lack of an ontology, a common ontology, something that was easy to understand ontology to. It shouldn't be something that's so complex that people don't get it, don't understand it. So we want to have something that we can do that with. So the need for that ontology is pretty clear cut. If without knowing what the information is, and particularly between different tools, you really can't have them work together. You're just passing garbage information back and forth. So the part of the reason that lifecycle modeling language was developed was to create a standard for this. And in fact, it provided and was mapped to the DODAF DM2, SysML charts. So everything else, IDF zeros, it's been linked to other things, other views of the information. So, but that's just data. It's just basically capturing the information, be able to visualize it and understand it. But as usual, very few vendors have adopted it, or anything else really as a real standard. And so, there is a group trying to build an ontology for SysML, but it's very likely to go the same way the DM2 has. Coordinate architecture data model before that was the CADM model that was in the earlier versions of DODAF and the C4IS architecture framework. And those kind of failed because they were very difficult to understand, overly complex, frankly, unnecessarily complex. LML really could be that standard that people are looking for if they want to take a look at it hard. It was designed by a group of systems engineers. I was a member of the group. I am a member of the group, I should say. I'm the secretary, actually. But the group's led by Dr. Warren Vanneman. He's a retired Navy captain. He's also a professor of practice at the Naval Postgraduate School. We had professors from George Mason, Stevens. We also had people from large companies, small companies. We tried to get a big cross section of people for it. It is being taught all over the world today, and so it is available. So you can learn it very easily. There's a nice new thin book, Essential LML. We like to compare it against the SysML books you need. There's 2 books apparently you need for SysML, and those are pretty long. Obviously, it's a very complex subject. Essential LML will get you into it very quickly and easily, and then the rest of it's available easily online. So if you go to lifecyclemodeling.org, you can learn a lot more about SysML itself and the steering group, and we always are looking for that help. So LML is giving us that strong ontology for systems engineering and program management. So Innoslate, it implements it. It was actually one of the things I actually had implemented it in another tool before we built Innoslate. And so it can be put in other places. It's not unique to, LML isn't unique to Innoslate, but we've done a lot with it. First of all, we've focused a lot on documents view. Documents view allows you to have an addressable individual paragraphs or sentences or however you want to break down the document that then can be traceable directly into things. But it's live, it looks like a document, it can be analyzed as a document, it can be worked on as a document. So we actually have a special version of that called the requirements view that brings in our quality checker for requirements. That's an NLP checker that actually reads the requirement and scores it against various criteria. We also have 24 different diagram types in our modeling right now, all the SysML9 diagrams there, but also IDF zeros, N squared charts, I squared charts, you name it, just tons of different views. And of course the LML diagram set. And then of course we also have a CAD viewer. So the purpose of that is start that, what we call now vertical integration. We're trying to take work that was done at the design engineering level and design engineering tools and bring it back up into this view so that you can work with it and understand it and validate that it actually did what you were expecting and met the requirements. We also have simulation. There's discrete event and Monte Carlo, and we're looking at other simulation types to add in the future. That, of course, can be used in the early part of the life cycle to make estimates, and then in the later part of the life cycle, once you start gathering data, that you can calibrate your simulations. They can now be used in lieu of some testing and things like that. And of course, there's a test center as well to capture all the test information. But systems engineering is more than just these things, more than just these technical views. We also have the programmatic views like risk, timelines, cost analysis. We need to be doing all these things. And so, of course, that has to be done in conjunction with program management. And so if you see, a lot of people get very confused, well, what's the difference between program management and systems engineering then? Well, you know, the systems engineer is focused on the system. So they're working at how to optimize cost, schedule, and performance for the system. The program manager is doing exactly the same thing for the program. So that's why there's a strong overlap, which, by the way, I highly recommend. There was an Incosi PMI book put out a couple of years ago. It's quite good. It gives you that understanding of that whole integration and how those are tightly coupled disciplines. So for vertical integration is what we're focusing on now. We feel like we've horizontally integrated the functionality that we need across the top part of the life cycle for systems engineering and program management. So now what we're trying to do is to tie into the other detailed design engineering tools. So one of the things we're looking at, of course, we have the CAD viewer already, but that's just a viewer. There's a lot more we can and probably will be doing with that in the near future. We just recently have integrated with Simulink. That's again very often used at the design engineering level, and it's a very nice tool for a whole variety of things. And we're continuing to look at how we can integrate with it even more tightly. We also have had others. One of our colleagues, Dr. Jerry Sellers, has actually done a lab view integration, and so to use with hardware in the loop testing. Kind of a very interesting use of that. Just so you know, Phoenix Integration is also working on developing integration with Innoslate, so that's ongoing. We hope to hear results from that very soon. There's also a number of other customers that are creating their own digital threads and their own design engineering tools, and we don't even know what they all are, which is fine. We don't have a need to know, but that's fine. Everyone wants to create their own threads as a competitive advantage. That's certainly reasonable and not unreasonable at all. But the question is, do we always want to integrate tools? When should the tools be integrated and when shouldn't they? So when should we? Okay, so first of all, that lack of common ontology means you have to really carefully select the tools you're going to integrate with, because you got to understand what the data is that's going in and out of each of the tools and making sure it is the same data object. Just because somebody says something's a function doesn't mean it's just that the word function is the same in your tool. It even means the same thing. Whereas we use actions in LML. Is that the same as a function in this other tool? Well, maybe yes, maybe no. Just to have to see what's really underlying that to make sure we understand that they really are the same thing or not. So that's very important to do. And unfortunately, right now, that's still sort of tool by tool unless everybody adopts a common ontology like LML. So we're currently selecting tools for various projects and working to bring them in together and work with customers to help them do that. And for the most part, you can still export and import. If nothing else, we've got a kind of a lowest common denominator in CSVs, comma separated values files. Or ideally, XML would be better, and there are various XML versions, XMI, but XMI, again, has been implemented differently in every tool, so that's not really very common. There's UPDM is another one that's out there but it gets extremely complex, and again, I think there's probably a lot of individual implementations of those things. RecIF is another one that's out there, actually for requirements. That's probably not bad, and can at least move data between requirements tools, at least, but it's still, since most people are using requirements tools as much more than just for requirements, it may be very complicated to do that. One of the things we're trying to do more of is move away from file exchange and try to do things more with APIs. Application programmer interfaces make it so much easier and quicker to move the data back and forth between tools. Most modern tools are using Java or REST APIs. We have both of those, plus we also have JavaScript APIs so that we can do stuff at that level. So that's another very interesting approach that we're using. Note that this data flows usually in one direction well, but not bi-directionally. Again, oftentimes what happens is the capabilities in one tool are different than another tool. And so the information then is different in each. And so even if you do just move the common information back and forth, you lose information going one way or another. So historically, I've told people don't go back and forth, go just one way with the data flow and design it that way. So the data gets captured one way and then migrates up or to the bigger picture. That seems to be a better approach to it. So again, one of our main things as systems engineers, we're trying to produce specifications for the design engineers, and then we want to take their results from the design engineering tools and import them into our system engineering database so we can tie them together, through, make the relationships to show that we've traced and that things have been met. And that's, again, part of what we're already doing with the CAD drawings in Innoslate. So that seamless integration between the systems engineering tools and design engineering tools probably isn't bridged too far at this time. I will say, again, until that common ontology gets worked out, it's going to be very, very challenging. But careful integration is you got to be careful of avoiding that garbage in, garbage out. So just be very wary of that as you're working with these tools and trying to make sure you have that common ontology. So when shouldn't we? Well, I started my career at a national laboratory working on physics-based simulations. And one of the things I learned very early was that there's a lot of theoretical limitations for the physics itself. We don't even understand the physics fully for some of the things we're modeling and simulating. We can use we have to use approximations, partly due to our lack of math capability. We can't solve many kinds of equations. And so, we have to apply these in areas where we don't even know the exact physics. I mean, a lot of what we do in modeling simulation has people in the loop. People are very hard to predict. And so that's when we get into more stochastic kinds of simulations where we're using probabilities. That's a much better way for us to work and model what we call behavior and simulate behavior. So the physics-based simulations require extensive calibration of experimental data if they're really going to be useful because of these problems. So oftentimes the simulation code will put in some kind of a knob, something you can adjust. It's not really a real parameter. So that's something I've seen done and works very well to match data, and then that way at least your simulation is producing the information in the way you expected. Of course, that makes it pretty fragile. It means it's not going to be necessarily useful the next time you use it. So understanding all these assumptions and approximations is very important. So you need to understand those boundary conditions of where is the simulation valid and when is it not. So that's another thing that has to be captured and categorized so that people can understand when to use which simulation. So one of the things you don't want to do is have poorly or non-analyzed simulations results, because if nothing else, that'll start piling up and you'll be introducing new errors to the system, you'll be causing new problems, and you'll cause more failures. So very often this is a situation where you want either an air gap or at least the analyst in the loop. Now, file exchange here might be the appropriate way of handling that. And again, I've used that over the years, and so that might be a better approach to this particular problem. So some of the problems with digital threads themselves, though, okay, we have to address some of the potential drawbacks. First of all, compiling all this data together may be actually impossible in terms of the amount of storage we need. Someone estimated that it took exabytes of data being produced from just a pair of jet engines on an aircraft today. Well, that's 10 to the 18th bytes of information. That's a lot of data. Where do we put all that? How do you find it? How do you search it? How do you get the data out that you need when you need it? That's very, very difficult. Another thing that happens is a security risk, right? You combine all this information together. Now, all of a sudden, all the flaws in the design are also available to people who maybe don't have your best interests at heart. I'm reminded often of the Death Star in Star Wars. You probably remember when they got the plans with the Death Star and they found the way to destroy it. And so that was the whole fight, and the big thing blows up at the end. Well, great, but Obviously, that's something we don't want to have happen with our systems, you know, particularly our life-sensitive or life-critical systems. So we want to work with that. A third area that I know is a big problem is intellectual property rights. People are very concerned about maintaining their intellectual property rights, and they should, because they've spent a lot of money, time, energy. It's maybe the basis of their business. And we have so much of that theft going on anyway, internationally, particularly. And so it's something that is a big, big concern. So, but these are all problems we have today. These are not new problems, really, if you think about it. So this is not, so how do we overcome the problems today? Oftentimes what we do is partition the problem as best you can to limit the information by who needs to see what. And so you know, even though we're supposed to be in the information sharing age, we still need to do a lot of information hiding as well. So we need to make sure that it makes sense. But I think with the proper systems engineering, we can design the tool environment we need for the future. So kind of summary, I think LML gives us a path, if you want to, for the future systems engineering and particularly digital engineering. And another thing we're going to have to do is make sure we're adopting the tools that are coming out, things like cloud-based tools. We've been waiting for, we started development of Innoslate back in 2010, thinking cloud computing would be ubiquitous everywhere by now. Well, it sort of is and sort of isn't. They still have a lot of customers who are absolutely terrified of having their stuff out on the cloud, on the public cloud. Well, that's fine. They're private clouds. They're hybrid clouds. There's all kinds of it. The technology is the same. Doesn't matter how you put boundaries you put around it. It's the same technology. So that's extremely helpful. The other we found extremely useful is the NLP, natural language processing and machine learning. So those technologies are branches of artificial intelligence that are very usable today and very accessible. And in fact, we've implemented those technologies, both the cloud computing and NLP and machine learning, to today's product in Innoslate. So we actually have quite a bit of work in there. We need to keep doing that. We need to keep looking for new things, new technologies, new ways to bring the data in. And we definitely recommend everybody at least look at LML, see if they can't use it. I think they can. It's fairly easy to map to. It's fairly easy to develop your outputs with it. And again, we never thought LML would be the 100% solution. It's the 80% solution, but it's that common set of data you want to use. But I don't think we design future systems using old methods and old tools. I think we need to make sure we're using the latest and greatest technologies. We're certainly not going to speed up the process by doing things the same way, even though it might look like we're doing digital. If we're doing the same kinds of things we did in paper and having to follow the same kinds of processes, it's always going to take a long time, and it's going to be very difficult. So we need to embrace the new technologies, not hamper them. And of course, one of my favorite movies is Iron Man, and here it is with Tony Stark in his lab. And we're not that far from that future. We really aren't. And I'm pretty excited about making this a reality myself. So that's all I had today. Open for questions. Do we have any questions, Elizabeth?
We do. We have a few so far. If you haven't done so, please use that panel on the right to ask us your questions, and feel free to ask as many as you have. Our first question is from a lot earlier. What's the title of the PMI book that you just mentioned?
Oh gosh, you know, normally it's sitting on my desk and I could actually just tell you it exactly. But I think if you just Google Incosi PMI book, you'll find it pretty quickly and easily.
Our next question is, could you please define API again?
Sure, application programmer interface. It's we used to call them library calls back when it was when we were using Fortran and things like that. It's just a way we access information capabilities from other software elements. So it's a great way to access the information that you're trying to do. So it allows you to do things like in the database, go in, find information, bring it out, use it, or even put information into a database. So very helpful with that.
Our next question is, how do we include LML in any and all systems engineering tools?
Well, since it's an open standard, it means it's free for everybody to use, so anybody can adopt it. Many of the tools have the ability to adjust their schemas. For example, Doors. Doors really doesn't have a set schema, so you could easily add it there. I prototyped it in Core, so I know it has that capability. Cradle, I believe, also has a schema editor and extender. So a number of these tools can use this effectively. Obviously, some of it's going to require the vendors themselves to do more, like show the LML action diagram and things like that. But for the most part, you can use a lot of it in other tools.
The next question is actually the same as the last question, so I think that was answered.
Okay.
And the next question is, can you provide details on Innoslate NLP/ML capabilities?
Sure. So right now we have 3 different areas we use NLP and machine learning. So first of all, for machine learning, what we found was because we created an enterprise version, and most people are using the enterprise version, what we had to do was pre-train the algorithms. So we used machine learning to help us do that with the cloud. And then we took those algorithms and applied them to using NLP to do the actual reading of things like the text and things like that, and matching information. So the 3 areas we do it right now is the requirements quality checker. So that checks 6 out of 8 parameters for is it clear, complete, consistent, that kind of thing for the requirements. We also have a requirements traceability capability, so we can actually look and see, should these things be connected to each other? Do they have enough information in the name, number, and description that will allow me to say, yes, those 2 things belong together? So we actually use that in our traceability matrix. And that's actually not just for requirements traceability, that's for any kind of traceability. You're trying to connect 2 different types of things, the relationship, it'll help you do that. And then the 3rd area is something called Intelligence View. Intelligence View is a set of heuristics, which are best practices that came to us from work done at Naval Postgraduate School and Stevens Institute of Technology. Dr. Christian Gianmarco was the primary person who did that work, who was leading that work. And so we've applied those in the tool, and actually we have the ability to put fixes in. You can actually fix things and make it work that way. So all that's available in our online documentation. You can find it in much more detail there.
I think I have the name of the book that you had mentioned earlier, and correct me if I'm wrong, Steve. Was it Integrating Program Management and Systems Engineering?
That sounds right.
All right. Well, I think we got the answer to that question then.
Okay.
Our next question is, where would one find out more about the Air Force's study?
The Air Force's study. Not sure what study that's referencing exactly. I know the Air Force is using the tool in something called the AFCERC. It's the Air Force's Systems Engineering Resource Center. And so it is being used quite a bit by the Air Force, as well as the Navy and other organizations. But maybe we get clarification on that a little bit more later.
Yeah, we can reach out afterwards. This is the study that you started the presentation with.
Mm-hmm.
Our next question is, can universities get Innoslate for free for course use?
Oh, I'm sorry. So can I go back to what did you say about the study I was mentioning?
He was clarifying that what he was talking about was the study that you had started the presentation with, the Air Force study.
Oh, I'm sorry, AFRL. Yes, I'm sorry. That was the digital engineering thread activity. So they had a website for that. It was down last I heard. So I don't even know I have a contact easily available for that, but we can try to get you that contact. I know I've been bugging them for when they're going to put it back up. Because they had audios with each of those, explain them. It was actually extremely useful. So they lost some kind of funding or something and it had to pull the site. So.
I've made a note of it, and we can reach out to you afterwards.
Okay.
Our next question is, how would you do configuration management of a system?
So, so configuration management is handled a lot by the tool itself. It actually is configuration managing the data for you because we capture history. And so we track everything that way. And you can see what changes have been made. You can even revert back to previous changes. Another thing we have is baselining in the documents view. So you can baseline the documents, and that's another way to help do some of your configuration management. We have a similar concept in Test Center for the test cycles. So you can create test cycles and have those be basically baselined, same kind of idea. So that, that way you can freeze that data and keep it under configuration control. So obviously you would have to apply configuration management processes over all this to make sure you're doing the things you need to do and you're baselining with the right version numbers and things like that. But fundamentally, it does help you do a lot of that. The heavy lifting part of that.
Our next question is there any work going on to integrate ConOps modeling tools such as AGI's, STK, or others?
Yes, actually, very much so. We are looking at STK specifically, and want to see if we can integrate with that. They have a new web version of it that we're actually anxious to really look at and see if we can do something with. So we do have a project that we're looking at internally for that, and also working with some student projects at George Mason on that one.
We have one last question. What capabilities do you have planned for Innoslate to move forward with digital engineering?
We feel like we've done a pretty good job already with the top layer. It's now this integrating with the design engineering tools and bringing them into play. And again, we want to do that judiciously. We're heavily focused on providing those interfaces with some of the key tools. STK was mentioned to be one of them. Obviously, Simulink was one of those as well. So we have a number of those that we're looking at, but we're also looking for people's thoughts and ideas. I know ANSYS tools was another one group we're talking to a lot. We'd like to do something more with them. So those are just some of the ones we're looking at, but I don't have a complete list, and I'm not sure I've got it if there is such a thing as a complete list. And so the key is if those are ones you want us to do, great. If you've got ones that you'd like to help us prioritize, please let us know. That's what our feedback form is for on our dashboard. So please feel free to use that to let us know more of what you'd like to see in the tool across the board.
We just received a couple more questions, and we do have some time, so I'm going to go ahead and ask them. What reference would you recommend to quickly learn LML?
So I think Essential LML is a good place to start. The book I showed earlier, that's available on Amazon. Let me just go back up to that real quickly. Here we go. And it's very easy to find there. Just get that. It's very inexpensive. We purposely printed it inexpensively. We'd like students to be able to use it. Another new book that's coming out here very soon is something we're calling Real MBSE. And that should be available out, we're still hoping for this month, aren't we, Elizabeth?
Yes, very soon.
Yeah, so certainly, maybe in time for Christmas. Certainly hopefully by the first of the new year.
I think it'll be done by tomorrow, actually.
Oh, great. That's good to hear.
I apologize if I skipped this question earlier. Can universities get Innoslate for free for course use?
Yes, absolutely. The free use is one of our essential features. We really encourage the academic use of the tool. First of all, it's very easy to learn. It incorporates many different concepts and frameworks, so that you're not just having to teach one type. The fact that it's all web-based means that you don't have to download anything. The students don't have to download anything. So it means that whole hassle of getting it configured on your PC and all those other kind of things go away. It's completely browser-based. Also, we even for individual universities, we provide the organizational level for the professors then to manage the classes. They can create teams, set up different roles. It gives them a lot more flexibility. They can even create their own ontology, their own schema that's used by all the projects within it. So again, it gives them a lot more control, professors a lot more control over it. But it's been free for use on the regular academic version, which is the same version as the tool. It just limits the number of entities you can have. So all people have to do is sign up with their .edu address, and they're automatically upgraded to that academic version. But if you would like to have your own organization, please contact us, and we'll see what we can do to set that up.
All right, I think that was the last question that we had. We will, as always, be sending out the recording and the slide deck to everyone that attended today. For more resources, we encourage you to visit our website and our blog, as well as connect with us on social media through the Innoslate user group or through Twitter using the handle @Innoslate. That concludes today's presentation. Have a great rest of your day and a wonderful holiday.